Hello everyone. Today, I'm going to show you an incredible trick, transforming this simple plastic Coca-Cola bottle into a powerful, versatile tool. I'm opening the lid and pouring Coca-Cola into a small cup. I'm taking this bottle cap and drilling a precise hole right in its center. This is crucial because this hole needs to perfectly fit the base of our spark plug for a snug, secure connection later on. I'm inserting a spark plug into the hole I just drilled in the bottle cap. It's important to make sure it fits tightly. This ensures a stable connection and prepares it for the next steps. I'm taking our modified cap with the spark plug and screwing it securely onto the empty plastic bottle. This forms the main chamber of our device. I'm carefully drilling a small hole into the bottom of the bottle. This tiny opening will be used to thread our electrical wire through, allowing us to connect it internally without compromising the structural integrity of the bottle. I have this red electrical wire here. I'm threading the wire through the small hole at the bottom of the bottle. I'm going to peel off a small section of insulation at one end, exposing the copper wires. Then, I'm going to twist these wires tightly, ensuring a clean path for our electrical connection. Now, I'm connecting the stripped end of the red wire to the central electrode of the spark plug. I'm using a pair of pliers to twist the copper tightly around it, ensuring a solid electrical contact. This is critical for the device to function effectively. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. To make sure everything is sealed and secure, I'm applying hot glue around the base of the spark plug where it meets the bottle cap, and also around the wire entry point on the bottle. This will prevent any air or gas from escaping, which is vital for the device's performance. Now, for another interesting component, I have a used AA battery. I'm carefully peeling off its label and using pliers to remove the end caps. This allows me to access the internal components, specifically the carbon rod that runs through the center. I'll extract this carbon rod and give it a good clean with a tissue to remove any residue. This carbon rod will be the core of our next DIY tool. I'm inserting the clean carbon rod into the chuck of my drill, tightening it securely. This prepares it for rotational tasks. I'm using a piece of sandpaper to meticulously sharpen the end of the rod. The sharp end is crucial for precisely concentrating heat at the weld point, allowing for clean and efficient spot welds. I remove the carbon rod from the drill. I'm taking another red electrical wire and stripping both ends, exposing the copper. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. Now, I'm connecting one end of the stripped red wire to the outer metal casing of the spark plug. I'm ensuring a tight wrap to maximize electrical flow. With the remaining red wire, I will secure the exposed copper wire to the spark plug electrode. I'm attaching the carbon rod inside the electrode and tightening it. A strong, secure connection is absolutely essential here to ensure consistent and safe electrical conductivity. With the other end of the red wire, I will attach a red alligator clip to it. These clips will provide a convenient and secure way to connect our homemade tool to the battery, making it easy to use and disconnect. Here I have a white wire, and I'm carefully attaching each alligator clip to each end of the wire. This will act as a second electrical contact point, connecting to the other terminal of the battery. I'm now detaching the battery pack from my drill. This battery will serve as a power source for our unique creation, providing the energy needed for its various functions. I'm carefully connecting the red and white wires, each with an alligator clip, to the positive and negative terminals of the drill battery. This completes the circuit, sending power to our transformed spark plug device. I'll test it on 2 razor blades. See how it quickly heats up and melts through material? This shows an incredible potential for cutting and shaping various materials with precision and ease. For the next project, I'm preparing 2 small nuts and placing them on a piece of metal. I'm touching the spark plug to these 2 metal nuts. Do you see those sparks? You can see the intense heat and sparks as it welds into metal instantly. Amazingly effective for such a simple setup. Moving on to the next project, I'm taking a red electrical wire and attaching a small red alligator clip to it. I'm getting a pen and a piece of wire ready. I will wrap wire around the pen to make a spring. I will attach a spring to the negative wire of the device. In this project, I will clean a soldering iron that is covered in rust. I'm using a screwdriver to disassemble the soldering iron to prepare for cleaning. With the soldering iron removed, I will attach it to the positive wire. I will use the original Coca-Cola to make an electrolytic solution to clean rust. Then I'm adding a generous amount of salt. I'm stirring it thoroughly because the salt will increase the conductivity of the solution, which is essential for our electrolysis demonstration. I'm placing the red and white wire electrodes into the saltwater solution. This setup allows us to observe the effects of passing an electric current through the conductive liquid. Look at that. The moment I connect the battery, you can see the solution bubbling vigorously around the electrodes. This is electrolysis in action, where the electric current is breaking down the water and other compounds in the Coca-Cola. It's fascinating to see the chemical reactions unfold. After our electrolysis experiment, I'm carefully removing the electrodes from the solution and cleaning them with a tissue. This allows us to see the effects of the process on the metal and demonstrate how it can even clean some surfaces. The electrolysis process effectively cleaned the soldering iron, revealing another unexpected use for our homemade device. The two nuts were securely welded together using a homemade welding tool. I'm going to reconnect the wires to the battery and demonstrate its welding capabilities once more. I have a sieve with a broken handle, and I'm using a homemade welding machine to weld it back together. Watch my homemade soldering iron work on this metal surface. The powerful sparks demonstrate its ability to solder and melt metal. It's surprisingly powerful for something made from simple recycled materials. Here is our fully assembled multifunctional DIY tool. From a simple soda bottle, we've created a device capable of welding, soldering, electrolysis. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what other unexpected tools you'd like to see me create. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.